All right, welcome everybody to the 5th Gardeners and Growers Workshop. This is the 12th of February 2017. As usual, we just go through the various options that one can gain additional teaching, and that's through the agriculture to register for the agricultural teachings that are happening every Wednesday with Dr. Gatwa presenting, and then also as registering as a private student directly with the SSI program. And of course the 3 books. These are very, very essential to greater understanding of this technology. All right, today we're going to pick quite a difficult topic. It's the seasons and their effects on plants. And we're going to do this in 2 parts because it takes quite a lot of understanding to get through the concepts. It doesn't seem as simple as summer, winter, autumn, and spring, as we sort of told. So what I'm going to do is just to start off with is just to make a few opening statements. So our seasons are created because of the different positioning of the Earth in relation to the Sun. This interaction of the fields from the Sun and the fields from the Earth will be different all the time. They are not a constant field strength. This means that the nitrogen, oxygen, carbon, and hydrogen created in the upper atmosphere will have different field strengths at different times of the year. And the oxygen field strength in summer will be different to the oxygen field strength in winter. So as you can see, those are quite simple statements, but they are loaded with huge amounts and layers of information. And so what I try to do is to try and look at breaking them down, because it's no use me just saying those statements without trying to back them up with the real understanding of what is happening. So a lot of this is what we've been able to glean from the different teachings that Mr. Keshe has done on the private teachings. And so a lot of it is sort of our interpretation of what we think and how this works. And we just hope that it does lay a bit of a groundwork for further studying. And maybe sometimes we will also realize that our understanding wasn't quite right. But at least it is a start for others. So first of all, I'm going to break it up into different small little chunks of information, and then we'll open it up to question time, just so that people can understand the different concepts, and you'll see how they will build to create and how the seasons then affect the plants. So when we first look at this distance between the distance and gaps between plasmas, we know that we have 2 different plasmas. We have a gravitational attraction and a magnetical repulsion. So each plasma will have its own maggrav strength, and depending on the strength of those 2 plasmas, there will be a gap between the 2, and that strength dictates that gap. So sometimes it's closer and sometimes it's further apart. And as we move one of those plasmas, so the other one will move to reposition itself to maintain that gap. So we can apply the same thing to the Earth and the Sun. So somebody's microphone is open here. Let me just have a look. All right. So we look at the Earth. It's changing its position in relation to the Sun, and we have our seasons, as we've been told, with the tilt of the Earth. So that's changing. And this is the same process when we look at the positioning of the neutrons and protons in relation to the electrons as well. It all comes down to the positioning. Just an example there, if we have the center of an atom, the protons and neutrons, and each proton and neutron has its own magnetical gravitational field, and they sort of act as round magnets and will move in relation to one another. So if you move one, the other one moves to find a position because of the mag-grav strength of each of those four. And each one is in a continuous motion all the time. When you add an electron, which is of a weaker mag-grav field strength, they tend to be further away from the center, which is more gravitational. And so the electron will rotate around the protons and electrons in relation to its mag-grav positioning. And what I've tried to illustrate there is that the electron then moves in a band because it can come closer and can go further apart. And also just try and visualize this as a 3D representation, not as a flat two-dimensional piece. So you have this positioning of these different field strength plasmas all the time in relationship to one another. So you have this constant motion and positioning. I've equated that to the same as the solar system. When you look at the sun, and just bear in mind this is a flat representation, not a sort of a 3D, and what we sort of lead to understand at the moment is that the Earth rotates in a spiral formation. All the planets are behind the sun. But what I've just tried to illustrate here is that the Earth and the sun both have their own magnetical and gravitational fields, and the Earth's tilt in relation to the sun gives us our short-term seasons from the summer all the way through to winter. What struck me when I looked at this is that there's a lot of people around there that are forecasting, and quite accurately, long-term weather patterns and cycles that they've picked up over hundreds of years. And so I was just sort of wondering, you know, same as how an atom would move its position closer and further away from its center, so the Earth would be doing that in relation to the sun, you know, and even if it is only a few hundred or 1,000 kilometers that it is moving closer or further away from the sun over these long-term cycles, it might give us some answers as to why and explain why a lot of these people are picking up these weather cycles over a very long time, over 40 and 100 years. So that's just something to ponder there. And so essentially we have the interaction of the two plasmas. You get the sun and the Earth, and that interaction of where the two is your Coulomb barrier, or the Van Allen belt, which is around the Earth. And that is that interaction zone between the sun's fields and the Earth's fields. All right, so on that basics there, is there anybody that does have any questions or easy to understand? Carry on. Anybody? Nothing raised hands there. Okay.
No.
All right, that's good. That means you all understand, or you don't understand and don't want to ask a question. So I'll assume you all understand. All right, now we need to go in and look at, now that we've sort of understood this positioning, we go in and have a look at our universe of fields. And first of all, we have to look and sort of state that this universe that we live in exists in a plasma of hydrogen. And these are the principal fields that we work with. And this is what is dictated in this particular universe. Now, we are, whether it's from the sun, we get from the sun, and the center of our universe is we get magnetical rays of different strengths that are given off by the sun and the central sun of the universe. And these are our principal fields that we are dealing with. And these are the principal fields of hydrogen. So we get the interaction of the two plasmas, and so the fields from the sun I've just shown there in relation to the Earth. So we get the magnetical rays coming from the sun and coming to interact with the Earth's magnetic gravitational fields. Now, this interaction, at the point of interaction between the two maggrav fields of the Earth and the sun, leads to the creation of nitrogen in the upper atmosphere. So just bear in mind, we have the principal fields from the sun, which is the plasma of principal field of hydrogen. And when they interact at this, the magnetosphere, if you want to call it, upper atmosphere of the Earth, we create the nitrogen, but it's in a GANS form, and it's not the nitrogen gas as we know it. So just bear in mind, because that's very important. So at this interaction at the very outer edges there, we create the nitrogen GANS. Okay. Any questions on there before I continue? So I've just chunked them up into very small, just so that we do understand as we go along. Okay. All right, I will continue. Now, we can look at the creation of life at this boundary of our atmosphere. So nitrogen is the source of all life on Earth. Without nitrogen, there would be no life. The interaction of the principal hydrogens with each other leads to the creation of nitrogen in our upper atmosphere. And we've been told that nitrogen contains 7 neutrons, 7 protons, and 7 electrons. And nitrogen is the key structure in amino acids. So that's your cohans. And all life depends on nitrogen. So now you can see why the creation of nitrogen at the outer boundary is so important for life on this planet. So when we look at the positioning of Earth in relation to the sun, this dictates that at this boundary of interaction, nitrogen plasma is created from the principal hydrogens. In other words, so another way to state it is the maggrav fields of the sun interacting with the maggrav fields of the Earth, and at this point of interaction, nitrogen is created. And this is unique to Earth because of our position and relationship to the sun. When you have a look at the Sun and Jupiter interaction, so we have another Sun and planet interaction, but Jupiter is much further away. Jupiter is a gas giant composed mainly of hydrogen and helium. So at its boundary of interaction from the principal fields, which is the hydrogen, the sun creates, at this boundary interaction, we create hydrogen and helium. And that's essentially what Jupiter is made up of. And it can be said the same for Saturn. So because of their position in relation to the sun, they create hydrogen and helium in their atmospheres. Because of our position in relation to the sun, we create the nitrogen. So the nitrogen plasma is created at this outer boundary because of the field interactions. And as I said before, it's in a plasma state and it's not in the nitrogen gas state. And at the same time, the oxygen and carbon plasmas are also created from the nitrogen plasma. And essentially, the nitrogen plasma attracts additional fields of these principal fields, and that leads to the creation of the oxygen plasma. And when this nitrogen plasma releases additional fields, it leads to the creation of carbon. So you can see from the nitrogen, we create the carbon, oxygen, and the hydrogen. And that forms the basis for all life. That's your amino acid basis for all life on Earth. I've just tried to give a little bit of a picture here. So the blue curve is your outer boundary of your atmosphere, and the bottom brown is the Earth's surface. So at that, if we look at the top of the picture, at that interaction, at this boundary interaction, we create the nitrogen plasma, And from that, we create the carbons, oxygens, and hydrogens, leading to the creation of the amino acids. And as these come down closer to the interaction to the Earth's surfaces, so these amino acids interact with minerals and non-metallics, such as your magnesium and silicon, and this leads to the creation of plant life on Earth. And on the other side of the equation, these amino acids, with the interaction of the metals, such as iron, leads to the creation of man as we know it and animals on Earth. So it's just the basic amino acid structure with different interactions of the metals on Earth leads to the creation of the plant life or the animal life. Now, these fields of the carbon, oxygen, hydrogen, and nitrogen are constantly created in our upper atmosphere. There are billions and billions of interactions of the principal fields of hydrogen at this boundary. And as the Earth's position in relation to the Sun changes, even a slight change in that gap will lead to different field strengths of the carbon, oxygen, hydrogen, nitrogen being created at this boundary. Now, as the carbon and oxygen and hydrogen are created from the plasma of nitrogen, they have that connection because they've come from that same source. And they all have a connection to the principal fields from our Sun and universe. So that's due to the principal field of the hydrogen. And this explains why everything is connected to everything else in this universe, because it all comes from one source. Any questions on that one? Or comments at this stage? It's a lot of info to take in and to understand.
Jimmy, the central area of the universe is like our Sun, in other words, the hydrogen plasma, is it?
Yes, that's my understanding from the different teachings, is that our universe is based on the principal fields of hydrogen. Other universes will be different. But for our particular universe, it's the hydrogen. The principal field is the hydrogen.
Thank you.
Okay. All right. Any other questions? Is there no? All right. So I will continue. Okay, so now we need to look at the understanding of these field strength changes that are coming in. So when we look at the winter and summer on the southern hemisphere, obviously due to the tilt of the Earth, the southern hemisphere experiences winter as we are further away from the sun, and obviously you'd have summer in the northern hemisphere. Now it's this gap changes between the sun and the Earth, so the creation of the nitrogen of this boundary interaction will have a different field strength. Summer in the southern hemisphere means that this gap between the sun and the Earth is closer, so we've changed the conditions, and this change of condition means that the field strength of the nitrogen created at the boundary will be different. So every time this position between the sun and the Earth changes, we know we change the condition, and so that means the field strength of the nitrogen, which is originally created, will be different at this boundary all the time. What I've done here, this is just for demonstration purposes. I just thought I'd try and do it because some people are very visual. And so what I've done is, when you look at the horizontal axis, I've just got the 4 seasons. There's spring, summer, autumn, and winter. And the vertical axis is just sort of the field strength of the nitrogen plasma. And so what I've just tried to illustrate here with my nice squiggly lines is that In summertime, we would probably have a certain field strength of the nitrogen. And if you look at the winter, we would have a different field strength of the nitrogen plasma. So that's all that I'm trying to illustrate, is that so throughout the year, this field strength of the nitrogen plasma is going to be different all the time because of the changing in the condition. And then from that nitrogen plasma, we create the carbon and oxygen and hydrogen plasmas. And so those, because they've been created from that nitrogen, they will also exhibit the different field strengths during the different seasons. So that graph is there just to sort of illustrate that as we change in the conditions, which is the distance between the sun and the earth, the nitrogen plasma field strength will be different all the time. So depending on the seasons, your nitrogen plasma of summer will have a different field strength to that of spring, autumn, and winter. And just to reiterate, as the plasma of the carbon and oxygen and hydrogen are created from this plasma of nitrogen, these will also have the different field strengths according to these seasons, which are the gap between the sun and the earth. Now, when you look at the plants and the fields, the plants absorb specific fields at specific times of the year, same as us. There needs to be a matching field strength of what the plant needs and the field strength of the cohans, the carbon, oxygen, hydrogen, nitrogen that is created in our atmosphere. And the plants know this because it is linked into their DNA and RNA structure of the plant. Plants are very sensitive to these changes in the fields and will then only interact with those of a certain strength. So when I look at deciduous trees that lose their leaves in winter, it's because the field strength of the oxygen, carbon, and nitrogen that the tree was using to create CO2 has changed. So they shut the leaves down and the leaves drop off, fall to the ground on the plants because there's just no match, so they can't continue. These changes in the fields also affect the ripening of fruit at certain times of the year. And this is something I'll go into a bit more detail on the next workshop. Right, any questions at that stage? All right, so we'll look at leaves and CO2. Now we know we've all been dealing with our CO2 box, and the CO2 box setup is a representation of the leaf. So there's a diagram there of your typical CO2 box. So we have our zinc plate on the one side, your nano copper plate on the other side, and in the middle we originally create a field strength zone of carbon, which attracts the carbon fields coming in, and this carbon interacts with the oxygen, creating CO2 in our box. Now that CO2, as we create more and more CO2 in our box, that also then starts to act as a magnet, so we can also attract other CO2 from the atmosphere. But now we also start attracting the carbons and the oxygens and hydrogen and nitrogens, and these form on the surface of our water, and that creates our amino acids. Okay, so the CO2 essentially then pulls in the amino acid structure which sits on our surface of our water. And so we can look at the same structure but on a leaf. Because when you look at any leaf, there is always the shiny top surface of the leaf, and that is your nano coating surface. And then on the bottom surface of the leaf is generally sort of a matte color. So you can take any leaf, any plant, and you will always see and so essentially the difference between those two surfaces is also creating a condition to attract and create CO2 within that leaf structure. So you can look at each leaf is call it a CO2 reactor. So the same as our CO2 box. So every leaf out there is another CO2 reactor, and they create CO2 internally. And just like we create amino acids on the surface of our water, so the leaves create amino acids on the top surface of their leaf. And this shiny layer on all the leaves is essentially the amino acid. Essentially the food source for the plants. Now, in the first workshop, we showed you the different leaf structures and how each leaf structure created a different Magravs field. Now, we'll take that one step further, and that each leaf creates a different field strength of CO2 internally because of the change in that structure of the leaf. So when you look at, we've got the leaves there of parsley and passion fruit, and because their leaf structure is different, they're both creating CO2 internally within their leaf, but because the structure is different, it's the change of conditions. So the parsley will be creating a different CO2 field strength than the leaf of a passion fruit. And there's the same with a strawberry leaf and a fern leaf. So each one is creating a different field strength of CO2. And it's the same when you look at the distance from the ground, the plants and shrubs compared to your very tall trees. It's the same thing. The field strength of CO2 in the plants on the ground will be very different to the field strength of the CO2 in your tall trees. So everything changes because we have a change of condition. So each plant, due to its leaf shape, the color, the size, arrangement, all creates different field strengths of CO2 internally. And these different field strengths will attract the fields of your carbon, oxygen, hydrogen, nitrogen from the environment to create the amino acids on the surface of the leaf. But there needs to be a matching field strength of what the plant needs and the field strength of the coans that is available in order for the plants to grow. Questions at that stage?
One question, Jimmy, regarding the box. I thought the positive leg on the LED was to the nano plate. Is it? You've got it the other way around.
It's the negative to the nano.
Negative to the nano, eh?
Yeah.
Right. Thank you.
Okay. All right. So now we'll just go a bit deeper in trying to put all that information together, and we look at why plants die in winter. So, well, some plants will die and some plants just stop growing and lose their leaves and will just lie dormant during the winter period. So it's because they are absorbing different field strengths of the carbon, oxygen, hydrogen, nitrogen that is not compatible with the plant's DNA, RNA structure, so they cannot grow. So if we look at some plants that grow in summer and not in winter, or they lose their leaves in winter, is because that match in field strength of the CO2 and what's available in the environment is not the same because of the change in the gap of the Earth and the Sun, and we create different field strengths of the cohans in winter compared to the summer. And so each plant or tree has its own Magravs that is able to interact with the right fields. They have to find a match and then they're able to grow. If they don't find a match, there is no growth, or the plants just lie dormant during the winter months because they aren't able to create and attract the right fields between their leaves and produce the amino acids, which is the food for the plants. Plants growing in winter, as we say, each plant or tree has its own magravs and needs to interact with the right fields. So your plants that are able to grow in winter is because their structure and internal structure of the plant allows them to absorb and use the fields of the winter carbon, oxygen, hydrogen, and nitrogen to create their amino acids. And as again, as I said, the deciduous trees lose their leaves because the field strength coming in is no match for what they need, and so the leaves shut down and drop off, and then the plant just goes into a nice long sleep during the winter time because they cannot create the food that they need. As I said there, they lose their leaves in the winter, and essentially when the leaves die, it's the same as the gap between the two plates, between the two surfaces of the leaf closes, and so there can be no more field interactions. The internal structure of the leaf can't create the CO2 anymore, so the leaf just dies, changes color, and falls off the tree. So all the plant does is essentially just closes that gap down between the two surfaces of the leaf. Any questions at that stage? Now this came to, I had showed in one of the workshops our tomatoes that grew in winter last year. So I'll just show you a couple of the pictures of those. That was midwinter in July. And there were the tomatoes in September, so coming into the springtime. There was October with lovely tomatoes there. And so just to reiterate our feedback on that at that stage is during November, we were picking lovely tomatoes, say with real lovely tomato flavor. And then the summer really kicked in here, and we go from normal weather of 25 to 29, and then we have heat waves of 35 to 40 degrees. And this hit us at the end of November. So we had a change in condition, which was too much for unhappy. And within almost 2 weeks, they all just died. It was just such a shock to their system. Now, in looking at the tomatoes and trying to understand from what we've learned today is why they did grow during winter. So first of all, I've looked at why, because all we did to the tomato plants was we had CO2 GANS in the water for the plants, but I'd also quite religiously, I was spraying at least once a week the foliage of the tomatoes with the CO2. Now, if you have a look at, by us creating a CO2 environment with the plants that the tomatoes were happy to take in, my theory, and I say it's just a theory at this stage, is that when we had the weaker fields of the carbon, oxygen, hydrogen, nitrogen in the winter, which is interacting with the stronger fields of the CO2 environment that we had created around the plant, was it a case of the stronger environment feeding the weaker fields so that we could get stronger fields coming in of the right field strength for the tomato plants to continue to grow, where they could still find a match and grow? So that is what our thinking is, in that what the CO2 does to the environment. So it's not a fertilizer per se, but it creates this environment so that the plants can grow, and it changes the field strength of those fields coming in. So the winter fields, which be much of a weaker than the summer fields, but it's changing them so that the plant can still absorb those fields and continue to grow. And when I had a look at trying to understand why the plants then suddenly died, because it was very, very quick, it was possibly that the stronger, even though we had created the CO2 environment, the stronger fields of the summer coming in, of the cohans, interacting with maybe my weaker fields of the CO2, the plants couldn't find a match and they just died. There was just no way they could cope. The other thing was, maybe it was my fault in that, because I had also stopped spraying the plants with CO2 leading up to that sort of heat episode. So one wonders if I'd have continued to spray, maybe they would have survived. So we'll have to try that again next winter, or other people can try with different plants. So it just brings a bit of a deeper understanding of what is really happening with the plants, by understanding the differences of the field strengths of the amino acids in the summer and the winter time. Right, any questions at that stage? Or does everybody understand it's so easy?
Easy.
Easy, yeah, I thought it was very, very easy.
No, it's good information.
Well, that is so easy, Jim.
What is that, class?
You prepared it so well that it's so easy.
Oh, okay. So I never know whether it becomes so easy or so complicated that you don't know what I'm talking about. So.
No, he's right. You're a great presenter, Jimmy.
Okay, thanks a lot, Ross. All right, so this does lead us down to another track in taking this knowledge and applying it to our CO2 production. So I'm just going to hand you over to Lisa, because she does all our GANS making in the house. I do not touch any of the GANSes, so.
Right, hello everybody. There we go. So we're going to be talking about changing the CO2 field strength when we make our GANSes. Every time we make the GANS of CO2, we change the conditions. And there might be very small changes, but the changes result in us making CO2 with different field strengths, just like the difference of leaf structures in plants. So even just a very tiny difference in temperature, you know, doing it in the summer or the winter is going to change it dramatically, and even all the way through the winter or all the way through the summer. We'll get different field strengths because the Cohan changes field strength throughout the year. So what's coming into your box will be ever so slightly different. And we're capturing these different field strengths in our box every time we produce a new amount of CO2. So that is why we have started, upon instruction from Mr. Keshe, because we started understanding this, that you need to create what we call a mother CO2 box, or mother CO2 bottle. So I have one bottle where I store a large amount of CO2, and every time we make a new batch of CO2, we add some of this new CO2 to that bottle. Even if I'm making for other applications, I'm always adding to this bottle. So over time, you create a single bottle of CO2 that will have multitudes of field strengths, and that bottle will become your mother. So use from this bottle for all your medical and agricultural uses, because the greater variety of field strengths, the better the matching will be with the body and the plants. Okay, so anybody have any questions and discussion and feedback on that? Because I think it's quite important that we start understanding cell in a plant all has a slightly different field strength, and so to get good matches and to really start understanding that you're making a big difference to your plants or your health, we really need to start making lots of different types, even if, as I say, you're getting a little bit of a bit inventive, not only temperatures. For example, we've started adding a little bit of Epsom salt to the water, or some potassium nitrate to the water. We've created a GANS where I've made CO2 with the vary if you create your nano plate and add certain of those things while you are creating your nano, you will also create a different field and bring in the energies that way. So if anybody would like to give us a bit of feedback on what you may have tried with your CO2 boxes and some interesting observations of whether they work or not. I will say the calcium nitrate didn't work. Nothing happened. And Jimmy reckons it's because calcium is a balanced field structure, so that's why it doesn't work, whereas the potassium has an unbalanced field structure, just like salt. And this is why the salt creates the GANS in your box, and the same with potassium. So anybody have any queries or feedback on that one?
I take it the zinc plate is only a catalyst. Is that true, Lisa?
Yes, you know, when you're doing your CO2 the proper way with no current at all it's doing is creating the fields in between the plate and the two plates. So you shouldn't really, if you have it the correct distance and you don't have any current, you should get very little zinc. You might get a slight amount of zinc off, but very little zinc. So you should get mainly CO2.
I've got mine about 3.5 inches apart, and I'm going to do a separation. Gunny APAC and her husband showed an apparatus where you could separate the zinc from the CO2.
Yes, sort of different rates of dropping down so that you kind of bubble them and get, I have actually posted that up on the Plasma School Library because I think it's quite important, because maybe we can start understanding how much we're creating with what. I have done it before with bagging the plates, and I have made CO2 that way, but it's taken me months literally to get any decent amount. So I just stopped because I needed to get a decent amount of CO2. You know, I consider a week or 2 weeks a kind of a good length of time to let the thing go. And if you do it that way, you shouldn't get a lot of damage on your nano coating either.
Have you tried bubbling air through a mesh, a nano-coated copper mesh? I've done that.
I haven't tried that. I have bubbled though. And the problem with the bubbles is that your amino acids never form because they're constantly being put back into the water. So,
that's right.
Yeah. So
but you make a lot of CO2. Make a lot of GANS.
It does make a lot of GANS. I think it does help. But at one stage, I was doing it quite a lot at one stage, but then I was getting no aminos. So I stopped doing it so that I could start getting more of a collection of aminos going.
Same here. I stopped it.
The CO2 I've done with the potassium nitrate is very interesting because it's actually got tiny little granules of dark, which Mr. Keshe says that the nitrogen GANS is a darker color. And when we've tested it with our radish microgreens, it is really very effective in making them very strong. So yes, we're going to be adding that to our mixture of CO2s that we've got. The Epsom salt one, when I did it plain Epsom salt, I didn't get anything really. But I think if you mix it with normal salt and Epsom salt, then you will get a better reaction.
Have you used potassium hydroxide instead of sodium hydroxide?
I've actually ordered some. I haven't used it yet, but apparently you should only use, what was the ratio? I think about 10%.
Yes.
With the NaOH combined. And apparently that does help to create a really good nano coating, but not on its own, I don't think.
we've got to understand that everything we do changes the conditions. And so then we're going to create, it will still be the CO2, but it will have different field strengths. So, you know, that's why we have to be very aware of what we're doing all the time, because now we understand how every subtle change makes a huge difference.
I can present you a picture about the fields in the box, and this shows how the magnetic and gravitational fields are built up in some boxes for production of the CO2.
Have you got a picture there you want to share then, Klaus?
Yes, please.
All right, let me.
Thank you.
All right, we see that, thanks.
So this copper plates nano-coated, and in this box I give this box on the central heating oven in the house. It becomes warm, and it's with normally caustic, and I put the CO2 plates in the corner, and it's interesting. Only the outside, not the back side, is floating. It was all in the box, and the box is closed, and I sprayed normal caustic, and you can see how the field builds up on the front side.
Okay.
And nothing on the back side. But the whole box was closed.
Did you spray both sides?
I sprayed the whole box, and
okay.
You see that the fields are so strong that they build up in the middle, not on the back side.
No.
The dust was on the whole box. I sprayed the whole box. And so you can see as the field build up.
I suppose with your positioning of your plates, you've almost created that central field strength there where they're just focusing on nanocoating.
Yes, and so we see that the distance is very important. With your new friend, with the basalt stone, you can find the right distance for put up different fields. Okay.
Yes, okay.
So, thank you.
Okay.
All right. Any questions on the anything on the presentation? Does it make sense, or is it too far out there?
Makes a lot of sense.
Okay.
Did you use the Epsom salts because of the magnesium content in it having a connection to the soul of the plant?
Sorry, what is that question again?
You mentioned that you used Epsom salt.
Yes.
What was your reason for using that?
The magnesium is the central
the blood of the plant.
Yes.
Chlorophyll.
If you look at iron, it is the central core of blood, whereas magnesium is the central core of chlorophyll for plants. So one is what I have done is I've created CO2 as well, where I have put a magnesium rod behind the zinc rod in the air, not in the water at all. And I've created a very strange clumpy CO2 that kind of like coagulates together in clouds instead of going sort of flat in the bottle. And this also seems to be very beneficial to the plants. They like it. I've added that to our CO2 mix that we add to our plants as well.
Okay, very interesting. Have you made have you made an oxide of just magnesium?
Yes, we have.
How does that react?
It was white, eh?
Yes, it's a sort of a greyish white colour. I haven't really used it extensively because we live at the sea, very clean sea here, and so we make a lot of ocean GANS, and the ocean GANS is stunningly good for plants, and that has a huge amount of magnesium in it. That has every mineral on the planet in it, and it gives it in the sort of the ratios that living things need. So we make a lot of ocean GANS and add that to our plants, and it's quite a simple thing to make, and so a lot easier than doing just the magnesium GANS. But as I say, I have done it.
Okay, thank you.
Are there any other questions? Has anybody got a raised their hand or anything? So no. I don't see that one. No.
Oh, it's very quiet tonight.
You're quiet tonight, hey? All right.
Just one, excuse me, Jim, just before you start. One observation is that Australian gum trees aren't deciduous, as everybody knows, but
yes.
In fact, they drop their leaves during summer. But they create new leaves during spring and drop their leaves in summer.
It's almost like a continuous process because they don't really go bare, hey? Not that I've noticed.
No, they certainly don't go bare, but in fact, I've been raking up leaves every year in summer, yes. Huge amounts.
We just seem to pick up gum tree everything all the time, quite honestly. They drop branches too.
So the next workshop will continue with the effects of the seasons, and we'll look at more on the summer and different aspects of it. But it does give you a nice perspective overall perspective of what's really happening with the plants. So I hope you did enjoy it.
Has anybody got anything else they'd like to actually show us and chat about? Because we have got a bit of time today. We couldn't make it too long because, yeah, we've been having 43 degrees today. It's still about, I think, 30, yes. Our brains are a bit foggy today.
You got 43 today. Will you get 160 mils of rain tomorrow?
I hope not.
Probably 200 mils. So it's extremes.
I tell you what happened there. We had a huge amount of rain. In the last 2 days, we got 167 mils of rain, but we didn't get the forerunner of 43 degrees, fortunately.
Yes, fortunately, yeah.
But everything's a wash.
Ross?
Pardon?
Are you in Perth?
I'm 190 kilometres south of Perth, 150 kilometres inland.
Okay.
A dry zone.
Yeah, the weather's been relentless here. We've had 3-4 weeks of over 30, 35, 40 degrees, and it's just hasn't stopped. So it's been quite tough on everything and the plants.
Our aquaponic water is sitting at 31 degrees. That's like tepid bath water, and the roots are still white. All the hydroponic guys around us are throwing every lettuce away because they all have some kind of root disease. The bacteria attacks it. And ours are still going. Some of them are not too happy, but they're still going.
GANS is the answer, is it?
Yes. Yeah, we've seen spectacular results with this heat wave. And what I do as well is, and a lot of people can do it, is especially when in the mornings when you know you're going to get 35, 40 degree day, I just go out there and I take the liquid plasma water of CO2 and I just go around and I just spray all over the plants and the whole environment, just so that it just helps change that environment around the plants and makes them cope better.
It helps, definitely. I've
Yeah.
done that too. In the 40
Yes.
degree, they don't look like wilting.
No, they don't. You know, it looks like they're in a nice balmy 25, 26 degrees, and so it's quite something to see. All right, if there's any more questions, that will call it a day.
I thought Klaus was going to do a presentation.
Yeah, what Klaus has done is he sent us some of the pendulums for us to play with first.
Oh, I see.
And then practice, and then we'll be able to show you and explain what it's all about.
That's why I was actually asking where you are, Ross, because
Yeah.
they are basalt pendulums. And some of the basalt deposits are in Western Australia.
We're sitting on granite. The country rock is about 2 meters below us here, and it just goes on to, you know, for miles, because they put a bore down, 55-meter bore. They drop down 2 meters through the soil and then hit rock. For the rest of the distance to 55 meters, it goes through solid granite rock, but different colors, a light blue and a dark blue. So there's 2 layers of granite. Apparently, perhaps it is basalt. No, basalt is black, isn't it?
Yeah, basalt is slightly different, but there are a couple of deposits because it's a lava flow thing.
Yes.
Klaus, I think you'll be better to explain what it is if you want to come on.
Sorry, we can this week not start the workshop. My camera is not working, but in the
No, you can just talk. Yeah, you can just explain.
Yeah. Okay. This kind of basalt rock is a very special type. We can find it in Austria, just on one place, and this basalt has a specific resonance to the waters, to the water body, to all the waters in the universe. And with this basalt, when we have it in the left or right hand and move this stone, we create special fields. The stone has a magnetic, diamagnetic force. And when you move this pendulum, you move it between the natural magnetic fields, and we build up different new fields. And it's not only to show something, the basalt pendulum is an active stone. He builds up something. And with this stone, we can find different structures in the water and in the soil. And also we can look at the different energy lines and ground force points with this pendulum. And when we build up domes with GANS, we make this work 30 years with rock dust and special composts. And we can see that the plants can benefit from this field as we bring the normal magnetic magnetic field from the Earth in a homogeneous structure, and then the ions can run to the plants and we can bring it in normal for her metabolism. And the next time we can start to look at these different fields and how we can position the different GANSes for the plants in the right combination and then in the right distances and the right range. That's for my recipe.
Thanks, Klaus.
Thank you, Klaus.
I think the rock that we find here most productive is a import from Queensland, believe it or not, which is probably basalt. The local rock is not considered that good. for production of plants. My wife was a member of Men of the Trees, and they used to grow their seedlings, well, from the seed. We used to put the seeds into little containers, and they used to grow in pure rock dust with a little bit of fertilizer, a very small bit of fertilizer. But it still used to grow, but apparently the best rock dust is from Queensland, which is probably basalt. Would that be true, Lisa or Jimmy?
I don't know. We've just started investigating all different sources as what's out there.
Mm.
So, I could just give you an example. Klaus was showing us how to use the pendulums, and so you can measure the fields of your CO2. And so when we had measured our fields of the CO2 that Lisa makes, it gave us a radius of about 3 meters, so a diameter of 6 meters. The fields, you can measure the fields from the CO2. And so the whole idea with that is to find the correct points on the Earth and place the CO2 on those places, so that you're getting the Earth's fields to sort of magnify your plasma fields. And that's the whole idea of it at this stage. So it's very, very fascinating.
Yeah. What sort of a pendulum do you use? On a pendulum on a string, or do you use divining rods?
This is the basalt stone on a pendulum, and yeah.
Mm. Right.
When you be in contact with them, with the people of Man of the Tree, 2 of my teachers was 8 or 10 years ago in Perth by the people of Man of the Tree, and they worked with this. They had some workshops. Maybe they can help you. And we work also with a special compost from the soil. I would teach you this in the next time, to build up special boxes for the ozone hole. This is very important in Australia, and this is a very easy work. And the people from Man of the Tree know this work well. They work with the systems for many years. Please go in contact with, this was Sally Oldfield, called this lady.
Oh yes, I remember her.
Yes.
Thank you very much, Klaus. I'd be most interested in finding that. We plant trees on our property. As a matter of fact, we're no longer a member, but we're very interested in, my wife's very interested in trees and growing trees. Thanks very much, Klaus, for that information, and I'd be very interested in anything you can throw up for our rock type in Western Australia, which you must have come up against in Perth.
You can work with basalt in different ways. Every special corn form or diameter from these corns have a different spectrum of waves. It's all the same material, but when you make little rock dust and little stones, and between this are different frequencies from all the same material. And so we can work with, as Lisa mentioned, the different CO2s. We have, maybe you can, we have, I think a year ago, we have action, we become from all countries, we become CO2 to Austria, send it to Klaus, to Dr. Brilla. And this CO2 is very interesting from the spectrum.
Very good. Thank you, Klaus.
You're welcome. Thank you.
Thanks, Klaus and Ross. Anything else that anybody wants to show or mention or comment on?
I was preparing something, but in fact, it's not even in the stage for presentation. But I was assuming you had some sort of a presentation and we'll see about that later on. I can create something a bit later on, I think, around about March.
Okay. No, that'll be great then, Ross. Nice to have some different presenters on and do the different information. That'll be great.
And a different country too, mate. Down here, it's dry as you like. We don't get 167 mils every day. It's a particular storm.
Yes. No, it is a country of such differences. But if there's also anybody else that has got something that I'd like to present, just please get in touch with us, and then we can slot you in any of the weeks and show your work. So that'll be great if you can do that. All right, no more questions, and then we can call it a day. So that'll bring to the end the 5th workshop, dealing with the seasons, and we'll continue with that on the 26th of February and continue with more information. All right, thank you everybody for attending, and we hope you enjoyed it, and we'll see you next time.
Thanks, everybody.
Thanks very much, Jimmy and Lisa. Thank you.
Thank you very much.
Thanks.
Thank you. Thank you. Have a good evening. Thank you.
Thanks, class.
Bye.